Why not nuclear power? So nuclear power, and I'm going to focus here on new nuclear power first. I should point out that there's one nuclear power plant being built in the United States, well, it's 2 reactors in Georgia, the Vogtle plant, and the latest cost estimates are $34 billion, and for 2.3 megawatts, so that's over $15 per watt. And that compares with about $1 per watt for wind or solar. So it's all, the capital cost is like 15 times higher right now than new wind or solar. And it's taking, those reactors are taking 17 to 18 years now between planning and operation, versus right now, with new wind or solar is anywhere from 1 to 3 years. But so it takes, and rooftop solar is in fact half a year, 0.5 years. And there are some wind or solar that could take up to 5 years. But the bottom line is, and by the way, they've laid out in that Vogtle plant, they've laid out enough cement to lay a sidewalk between Miami and Seattle. And so this is all it's been doing so far, is emitting huge amounts of CO2 with no benefit. If you look at, and it takes, once you have a nuclear plant running, then there's a lot of energy that goes into refining uranium and mining the uranium, and also beyond the construction cost. So nuclear results in about 9 to 37 times more CO2 equivalent emissions and air pollution per kilowatt hour generated than wind. It takes 10 to 19 years between planning and operation versus 0.5 to 5 years at the most for wind or solar. It costs, and these numbers are even old because it's now even more than 4 to 5 times that of onshore wind and utility PV. It's closer per kilowatt hour. If you look at the Vogtle plant, it's closer to probably 6 or 7 times with a capital cost of 15 times. And it takes, in this, just these numbers, it takes 2 to 38 times longer to obtain 1/4 to 1/5 the CO2 savings per dollar than wind or solar. On top of that, the Intergovernmental Panel on Climate Change has concluded there's robust evidence and high agreement that increased use of nuclear leads to more weapons proliferation risk, meltdown risk, waste risk, and mining risk. So these are all problems that we don't have to deal with clean renewable electricity. And just to show that Vogtle is not an anomaly, here are the construction times and planning to operation times for several other plants. There's one in Finland, which just opened, well, it's theoretically open this year. That was after 22 years between planning and operation. But it just got closed down again for some more inspections. Hinkley Point is expected to be 18 to 19 years, although that's not even close to being finished. There's Vogtle, Flamanville in France, 19 years. Even in China, 13 to 14 years and 12 to 13 years. And in Sweden, which was back in the 70s, those were 10 to 18 years. Really, there's no plant that's ever been put up in less than 10 years between planning and operation. So that's a problem. If we want to solve 80% of the global warming problem by 2030, and that's 8 years away, we can't have a technology, we can't be putting all our money in a technology that won't even be ready for another average of 15 years from now. In terms of CO2 emissions, I mentioned 9 to 37 to 1. I'm going to skip the details, but here's the actual calculations for those of you who want to look at it later. And so why is it impossible for new nuclear to help solve global warming? Well, we can allow 500 gigatons of CO2 emissions after 2020. That's accumulated CO2 after 2020 to stay below 1.5 degrees warming. There's on the order of 40 gigatons of CO2 emitted per year these days. So eliminating 80% emissions by 2030 and 100% by 2050 would then result in about 340 gigatons of CO2 being emitted. So that would keep us in that range of 1.5 degrees. This requires reducing today's emissions about 10% per year from 2023 to 2030. As I mentioned, a new nuclear plant takes 10 to 19 years between planning and operation. So 15 years from now, well, that's going to be 2037 when you get the first plant rolling. And so it's not going to be helpful at all to get us to the 80% goal by 2030. In fact, it's an opportunity cost. It's taking huge amounts of money away from spending on clean renewable solutions, which can be put up in today 0.5 to 3 years. So it's really impossible for nuclear to avoid 1.5 degrees global warming. It is possible for WWS to do that. So I'm going to stop there. Here's some additional resources. There's a lot more if you're interested. But the bottom line conclusion is we need to focus on things that we know work. Clean, renewable electricity and electrical appliances are what, and machines are what work. What does not work is carbon capture, direct air capture, blue hydrogen, nuclear power, biomass, bioenergy. These are all opportunity costs, and we should not be spending money on them, at least for solving our climate pollution and energy security problems. So welcome any questions if we have time. Thank you very much.
Recording with disaster, investing in nuclear reactors with no solution to store the waste that a million years still won't erase. Chernobyl, Fukushima, why take the chance? We can meet our needs with our nuclear plants, saving Ontarians billions of dollars with wind, solar and Quebec water.